Hello, my name is Alexei Ledenev. I'm a senior cloud architect working for Do It International. I'm also a maintainer of several open source projects that I'm writing mainly in Go language. And today I'm going to talk about some Go command line tools I'm using for my development, tools that are available as part of Go SDK, and also tools that are available from awesome Go community. And the goal to give you some short overview, I have only 30 minutes, and give you a taste for these tools and encourage you to go and explore by yourself. Go is a mature language with a wide community. It started 10 years ago, and my journey with Go started. I started to program in Go 5 years ago. Then there was no IDE, and there was no debugger, native debugger for Go. But luckily for Go developers, out of the box, Go comes with a lot of tools, more than one could expect. Not only basic compiler and linker tools, but also tools for code formatting, for package management, for documentation, testing, benchmarking, profiling, a lot of tools to choose from. And of course, today I have very nice ideas like GoLand and Visual Studio Code Go and others. But underneath all these tools are still using tools from Go SDK and from community. While we have these IDE tools that it's easier to start today, but still, why to use a terminal? And the first reason is power. Actually, using tools directly will allow you to choose to use more options. Not all options are exposed for GUI. There are some flags, some options that are not exposed. There are multiple tools or many tools that are very valuable, and there is no GUI for these tools. Using tools is essential for automation. So you're building your CI/CD pipelines, you're piping multiple commands together with Linux pipes, writing shell scripts. So use these tools. And this allows you actually to achieve more productivity by combining all these tools together. And some tools work awesome on multiple files with single command line. You just can apply tool command for multiple files. And just the beauty of CLI, I personally like to work terminal, and I hope as many of you also. So let's start with the basic stuff. So the first thing you do when you install Go, I encourage you to go and write a Go help. You will see there a list of all tools available, like tools for building code and documentation and code format, plus static code analysis tools. And you also can go and explore each tools, and I encourage you to do so. There are multiple topics, additional topics about Go cache management and modules, and it's very detailed documentation. So please do get familiar with all of these tools. You may find them very useful. GoEnv can show you the current Go environment on your machine, where you can see where the Go cache directory is located, and if you are using Go proxy, so you can also see Go proxy. You can also update all these environment variables, and this will be applied to your Go environment. Different flags like default Go compiler flag, default linker flags, etc. You can also see specific environment variables like a Go proxy or Go cache, or you can export everything into JSON. This is actually multiple Go commands or tools support exporting output to JSON, so you can explore it as JSON. You can also query it with JQ tool. For example, query for Go proxy from JSON output. Next thing you do when you edit your code, actually you are going to format your code, and multiple editors today automatically do it for you using a GoFMT tool. But it is possible and it's recommended to use GoFMT tool also to perform a check style before you commit your code or before you merge pull request, to just validate that all files are formatted accordingly to Go style. So -L flag allows you to list those files that are not formatted as Go recommend. And you can also, before checking, for example, you can put a pre-commit hook and automatically format your code with GoFMT -W updating file. Or also, GoFMT can also simplify some syntax construct using a simplify flag -S. There is another tool called Go Imports, which actually is a superset of GoFMT tool. It does everything that GoFMT does, but also is able to automatically fix imports, adding a missing import statement or removing that one that you are not using. Okay, it can be done fully automatically. What is interesting, GoFMT can also be used for mechanical source transformation. Actually, it's you can rewrite code at scale, supplying rewrite rules as a pattern and replacement, where pattern and replacement both are valid Go expressions. So we can, for example, replace a bytes compare method with bytes equal method for all files in directory and subdirectories with one command. Okay, let's go exploring a bit. So there is a tool called Doc tool that allows you to actually explore documentation for standard library packages and for packages you install on your laptop. So GoDoc all strings, for example, will show documentation for string packages, and piping into this less allow me to quick navigate this documentation. I just don't see it very well. Okay. Things like searching, navigating. I can also see specific help for specific method, like for example for replace method. And what is also convenient, sometimes I would like to see the implementation, so provide the -src flag, and I can see the source code for this method. Okay, directly in terminal, just to see how it's implemented. Convenient, right? Another tool, GoDoc as a single word, actually is an offline HTTP server that includes all Go documentation, including also some Go tutorial and Go effective Go books. Plus, you can see the. I just open it. Yeah. You can also see, things like books, as I said, and you can also see documentation for all packages from standard libraries, but also from all libraries and packages you installed on your machine or on your project. So it's very convenient, available offline if you are in place without internet connectivity. You have all documentations available. Okay. Let's go to next thing. Dependency. Okay, I want to talk a little about dependency inspection. So I'm switching to one of my projects, real projects, and let's say I have there, it's a simple project. I have only one file, but it may contain more files. Main Go. As you can see, it imports some standard libraries, but also some third-party libraries like JWT Go and CLI and Google OS 2. if I would like to explore all packages, my project is dependent on all modules I'm importing, I can use Go list tool. Go list also all packages, direct and indirect. But if you with -m, I can see the same information for modules, where I can see the module and module version I'm using. And if you open help, there is a flag called format. You can use it to format output, but also you can use it to filter the result. And you can filter based on package structure or based on module structure. And I'll show some examples. For example, Go list with imports. I'm taking only imports part of packages, and it's a direct packages I'm importing, and splitting with the new line, and I can see directly imported packages in my project. A more complex example, I would like to show all modules that are not indirect, since this is the flag, meaning I would like to show modules that are directly imported into my project that have updates. And for this, you are using the syntax I'm using is the Go template syntax. So it also allows you not only select things, but also have a functions, conditions, and etc. So, and right now, the last 4 lines contains all directly imported modules that have updates. So see the version I'm using and version that is available. Okay. There is another tool that helps me to understand why specific package is included into my project. Meaning maybe somebody brings it in directly. So it's called depth. And I'm asking it to explain why regexp is used in my project. Actually, it scans all direct and indirect packages and build a dependency tree. So I can see that it's used inside it's also used directly inside CLI package, but also indirectly inside CLI package, and also for IAM credentials, Google IAM credentials. Another nice tool I'm using is actually a tool that helps me to understand the licenses used by all third-party libraries I'm importing. Okay, which is very important since Go is a statically built. You compile it as a static binary file, single file. Every code from the third-party libraries is embedded into your binary file. So it's important to understand if your code is compliant to the licenses, and if there are some licenses you would like to avoid, you should know this. Okay, it's possible to do it manually to go through all directories, but luckily for us there are some tools. One of them called Go license. I can also configure it with JSON file. Show it later a bit. What's nice about these tools? It doesn't scan the import files, but actually looks at the binary itself and understand what packages are embedded into this binary. So, and for these packages, it fetches licenses from GitHub. You see there are some MIT license, BSD license I'm using. There is some package that it failed to detect license. So I can edit my configuration file and specifically list the license that I allow or license I would like to deny. For example, LGPL license, different version of LGPL license. And for packages that it fails to detect, I can provide the license. Go inspect code manually. Sometimes people write license term as a comment, sometimes in different text files. So I can go explore or at least ask author to add license. Okay. Let's go to build. So again, I'm going to a different project, and Go can build code for multiple platforms and multiple architectures. If you like to see what architectures and platforms are supported, you run go tools dist list. It's just output all permutation, all supported permutations like Linux, AMD 64, ARM processor, BSD, Mac, Windows. These all targets you can compile your binary. In order to compile binary to specific platform, I need to provide two environment variables, Go OS and Go Arc. For example, I'm providing Linux and AMD 64, and I'm building my application. And I would also like to build it for Windows AMD 64. Okay. Inspecting binary files, you can see that the first one is ELF Linux file, binary file, and the second one, Go Up Windows, is a Windows executable. So it's easy to cross-compile your application for multiple platforms. GoTool link can show you multiple flags for linker I can provide. I'm using here, for example, I'm using -x flag. It allows you to override the variables in your code during the build and link time. So, for example, I am using it frequently to embed version information into my binary file while building it. I'm taking git tag as a version and git commit, git branch, and current date. Okay. So running it with -ld flag -6, I can override variables in package, providing syntax package and variable name. I can override as exported data. And you can see it's compiled, and the current version includes all this information. Let's continue with the build a bit. By default, Go, which is binary, is statically linked, but not exactly, since for Linux platform it uses libc, libthread, and some other libraries depending on packages you are importing or if you're using C runtime. And if you would like to create a portable Go static binary, it's not dependent on external libraries, use Go enable flag. Actually, the code will be embedded into Go, and it's a replacement for libc function with Go native function. And thus, you actually, when you, for example, compile code in Debian and would like to run it on Alpine Linux, which is very popular Linux for Docker containers. So it's better to compile it with Go enable or compile it with Alpine. Another flags I'm using for release is -s to me to debug table information, -w to me to draft simple table. But again, explore the link options you have. You will have smaller binary. You can improve a lot of things. Build tags is another nice feature I encourage you to explore. Actually, the comment you put on top of file plus build and then specifying tags strings allows you to include this file to compile it only when tags is provided. And there are some out-of-the-box tags, for example, operating system and architecture. These tags provided out of the box. So if you have code that is OS specific or architecture specific, just put the build tag comment on top of it. But you can also provide your own tags. For example, you have code that is relevant only for integration testing. So you put a tag called integration, and you can use it as -tags flag while you're building or running your tests. Okay. And talking about tests, you have a Go test tool to run Go test. You can select a specific test, run all test and package, And you can automatically create code coverage. You can run tests with, if you have a good coverage, it's worth to try to run it with race detection, with race flag, to detect race conditions. And I'm a lazy guy, so I don't like to write a lot of boilerplate code for testing, so I'm using Go test to generate a test template, table-driven tests, and mock generation tools like Makefile, and to generate a mock for all Go interfaces. I'll demo this too. For example, I have a code, pretty simple one. Only one interface with single method send charge notification, and charge method called charge user that actually uses the SMS service that implements this interface and it's supposed to send SMS notification. So obviously I would like to mock this interface and I would like auto-generate code for all methods. So in order to generate code for all methods, I use Go test tools, and it automatically generate table-driven test methods. I just need to populate tables with arguments, and I'm ready to go. Maybe to put some meat inside the test code, which is I am doing when I'm using mock. Okay. So to generate mock, I'm using Mockery. It will generate mock, which is integrated with Testify testing framework. And something like this. So I can use a function like assert if function was invoked, if it was invoked with appropriate parameters and the amount of times I would like to invoke it. And prepared actually test code itself that is using mock. So these are automatically generated codes, but I just added, for example, mock implementation here. A call to my mock function and assertion that it's been called with appropriate parameters. And then I'm running test with Go test. I'm actually using rich Go test. It's just add some nice colors to test output. So you can see, first of all, test passed or failed, and also see, since I run it with cover, so I see test coverage information. Okay. As I said, Go also includes a lot of other tools. So you have a benchmark embedded into Go. You can write specific benchmark, and that's I'm going to demo how to do it pretty fast. Let's say I have a function, an anonymizer function that actually takes a string and searches for email address and replaces it with stars. Okay, pretty basic code. Uses regex to do this. And I have a test function that actually have two benchmarks, one testing with single email address, another with multiple email addresses. So running test with -bench flag, I'm running the benchmark, outputting it simultaneously into file and std out. I have another version of anonymizer, which is slightly a bit faster, supposed to be a bit faster, since I'm taking this regex compile statement from the function to init function of the module. It will be called only once. And I run my benchmarks, produce a new benchmark result. And using a tool called benchcomp, I can take the results and compare them, just to see how different they are and if I get any improvements here. So you can see it's an improved 50% for the simple case. Okay, I have only 5 minutes left, so I run fast my description. show only one demo. So static analysis. For static analysis, you have tools like built-in tools like web that allows you to detect some errors, and there are a lot of other linters that focuses on different kinds of errors. I'll show you this also. Let's say I have a code here. What it does, it actually takes a list of configuration files, JSON configuration files, open these files in Go routine, each one in Go separate Go routine, and to search for a specific key. Let's say AWS secret key, output the name of the file. Pretty simple. Utility. So I'm running a build, it compiles, it's a valid Go syntax, no problems here. But if I'm running a web, it can automatically detect that I'm using, inside the Go function, I'm using a variable that is defined in the loop above. So it can be changed during the code execution. Okay. There's also some problems with print statement. I miss a variable in printf and I use a variable in println. So just to show errors. Fcheck tool, for example, can check that for unchecked errors, unmarshaled, JSON unmarshaled. I don't check error there, so it reports on this. It's nice, but there is another tool which is a kind of linter aggregator called GoLang CID, very long name. It knows how to run all these tools together, web and Fcheck plus 30 different linters. You can run it on the same code, you can see nice output. You can also inspect what linters are supported. The list is very long. Out of the box, it supports a lot of linters, and they constantly add more. You can customize every linter you would like to enable or disable. You can parameterize linters, and you can run, for example, enable all, which is you run all linters on my code to detect a lot of other errors. I have 2 minutes left, let's try to run fast. Profiling, we have a separate session later on, so I will skip the profiling. It's possible to put the profile embedded into Go tools. So hopefully it will be covered in the next session. For build automation, I'm using, actually, build automation is different from compilation. You run you have multiple phases, you run multiple tools. It's not exactly like compiling. You run different tools for each phase. I try to make it language and tool agnostic, to run it on multiple platforms, using environment variables, file type variables. So I'm using Makefile. And if you pay attention to multiple projects in GitHub, using Makefile to perform these tasks. Just example of Makefile, we'll look at it later. As for Docker, maybe this will be the last slide I'll cover. It's actually when you build a Go code with Docker, you can use multi-stage build. This applying Docker build pattern where you have at least one or more stages for building and testing your code. And as I said, if you like to run a test with race condition, it's recommended to run it with GoLang, not Alpine version. Okay, like take it as a base image. When you just copy your Go mode, Go some functions, you can, if you're running with experimental build, you can reuse external cache for Go mode. And then run a Makefile or run a Go tools. And the final release image will include, I usually tend to create image from scratch, meaning empty Docker images without any Linux package manager, not Alpine, not everything. Since it's Go, it's statically compiled with cgo enable. And I put there only binary and define this entry point. Okay, guys, thank you. I wanted to talk a bit more, but time is up.